This is my FarmBeats station number 4, and it uses a Raspberry Pi on the bottom. It's the latest model, Model 4, and on top of that is an older version, the first version of the Seed Studio Raspberry Pi hat for the Grove devices. And you can see that there's quite a number connected here. Many of the original FarmBeat Grover devices are connected, but I've replaced the DH11 with an SH31, which is this one here. So it does the same thing, but I have software drivers for it on Node-RED, and that's the reason I replaced that. So in addition to the original Grove, to the original FarmBeats components, and you can see those here. There's the soil moisture, there's the soil temperature, the buttons, but I've duplicated that and I've got 2 more buttons on. And I've also added an LED over here. And next to that there's a push button, and I've replaced the Grove Sun with a digital light sensor that has been calibrated in lux. And next to that there's an analog light sensor, and it's using a photo transistor. And there's also a potentiometer here. So it's called the rotary angle sensor, and all of those devices go straight into the Grove hat. And I forgot to mention there's a relay, and it's using an older version of the Raspberry Pi operating system called Buster, which is about 2 years old. And similarly, the Node-RED version that I'm using is also old, version 1.0.3, and the reason for that is that Seed Studio has not updated their library for Grove devices on Node-RED. And so in the next portion of the video, stay tuned, and I'll give you a walkthrough on the program that's running on this. So the program's running is called Node-RED, and it's on the Raspberry Pi. So this is the Node-RED program that I have running as a demonstration only. So it's not the FarmBeats compatible program, but it gives you an illustration of the various flows and interaction. And on the left there's a palette here of various nodes. So what you do if you're interested in a particular node, say we wanted one called function, we would just drag that across onto the work area, and we then link it up. So if we wanted to, we can just link that up with another node, and if we wanted to trigger it, we can manually trigger it with this node. And we set the properties using the payload type. So the data type is shown over here, and if we wanted to make that a Boolean type, it would then send a true value onto the next node. Now, this particular node here is a template, and you fill that out with JavaScript code. And there's an example of one over here, which is looking at the value of the potentiometer, and the value comes in to the node as a message.payload. And I'm setting a global variable called pot value to the input, and that makes the variable pot value available on any node on this sheet. And to give you a bit of an illustration, these nodes here are the Raspberry Pi nodes, and they give you access to the GPIO ports. And if you open those up, you can see these have been configured. This one's been configured for GPIO 24, and it's looking at the hardware down here, the blue button. When I press the blue button, it will then activate that node. So down here I've got a grow button, but I'm also talking to the dual buttons, the blue, red, white and green buttons, using these general purpose nodes. Now the other nodes that I've got down here are supporting the Grove modules. In this case, the digital light sensor. And if I open that up, you can see that there's nothing to really fill out. It goes to the I2C port, and the data goes out to this message over here. The next node has nothing to be configured on that one, and it's talking to the, I had to do special wiring on this one. So if you look at the wiring on the Grove hat for Raspberry Pi, I've had to put that in directly on the GPIO pins, and the pin, the yellow wire there, is connected to the Grove sensor for soil temperature. So that's a special arrangement on that one. The next one is a Grove air quality sensor, and in this case it goes to an analog port. So going to analog port 6, and the next one goes to the capacitive moisture sensor, and it's going to analog 0. Now the next one's interesting, because what's happening here is that I'm running a Unix shell or a Linux shell, and there's the command, and that's talking directly to the Python library program or Python shell that was constructed by Seed Studio. And in this case I also have to append 0, because that moisture sensor goes to analog 0 port, and it terminates that it spawns a shell and terminates it within 0.2 seconds. And I'm doing the same not only for a Grove moisture sensor, but I'm doing the same for the pot over here too. And the pot value goes into a function. So it's connected to a number of nodes. Some of these are just sensing the values that come out of the shell. And this particular one, if we open it up, is the one that we've seen before. And it extracts the value and converts that into a value ready to be transmitted. And I transmit it by triggering it here, and it transmits it to a MQTT server with that topic. So there's a topic value. So if we actually trigger some of those, we can see what's happening. So to clear, over here on the right, we get the output of these nodes. So one of these green nodes, if I actually press a button, say I press the green button, I go down here and press the green button, then the output value of that is shown over here. So it gives me a topic value and it gives me a payload. So we did a transition here from 0 to 1. And you can see that. And we're actually, we'll only look at the current flows at the moment, and select those and clear it. Now to actually trigger some of these, I'm going to get the value here from the light sensor. So if I press that, activate that injector node here, just by pressing that, and I go across to the message area, it shows me the topic payload and it gives me a value directly in lux. But it also gives me some extra information about the contribution of infrared radiation. So we get 3392 as a proportion of the total bandwidth for infrared radiation. And we can do the same with the others. If I want to get this other flow here, and these flows are all independent. It's a very interesting example of parallel processing. So they're all working as separate little streams, which is part of the data flow model. So if I just press true on that one, and we go across and see the message, this is what we get. You can see the payload is 29.31, and that's the temperature of the soil temperature probe. And it's given me some more information down there. And just to see some of the other ones, if we clear all those and go back and see the soil capacitive sensor, we'll get a message over here, and it tells us there's a value of 612 on the payload for the soil moisture sensor. And we can do the same thing with the Unix shell here. So if I go down here and press true, we get quite a number of outputs here. It's telling us there's if you look at these ones, that it's detecting soil moisture. But interesting, it gives a different value, and it says that it's wet. So we'll clear those again and just have a look at the last one. The last one's interesting because what we're doing here is using the potentiometer. So this is called the rotary angle. I can turn that for different angles, and I can then inquire what the angle is just by pressing that button. And we'll go and look at the payload, and it's telling me what the value is. Now, considering that I'm using a analog to digital converter with 1,000 units, that if I turn that in one extreme and press the button again, you can see that that's going to go, it didn't change on that occasion. So what we can do is we'll do that one again, and it's gone to 0. And I'll do it to the other extreme, press the rotary angle, and we'll see what the value is there. Well, haven't changed it. Okay, and that's been transmitted via MQTT. And if we go to another computer and look at a different Node-RED program, we can see that the value has there is a node, there is a flow on that takes in MQTT from the server, and it then displays the results, and the